We are back here and have another interesting presentation within our Innomotics stage program. In this case, it will be a joint presentation together with Siemens, so I'm very happy about that we can offer that. And as you can see on the picture behind me, it will all be about starting and speeding up. And therefore, we have two experts to explain us how our high-efficient motors can be started in a very smooth and smart way, and also how you can benefit from an upgrade to IE4 motors. So, like to welcome our two experts here on stage, Thomas Kraus and Erich Fröhlich. Welcome. Good to have you here. So, Thomas is one of our promotion managers for Innomotics low voltage motors. And Erich, he's the product owner for the electronic starting solutions at Siemens. Good to have you here. So let's get out of the starting blocks. Maybe, Thomas, can you pick us up again a bit more? Why is it so important in industry to take a note on the energy efficiency?
Yeah, so the answer is that more than 70% of the energy produced is consumed by electric motor. So from this reason, all the efficiency regulations are targeting on motor parameters, and the other way around, all the motor development is focused on energy efficiency. Innomotics is offering a comprehensive high-efficient portfolio of LV motors, fulfilling the IE5 efficiency class in the reluctance and permanent magnet technology, also reaching the levels of the proposed IE6 class. Today, we are talking about starting of the classical induction motors or asynchronous motors, which can run directly on the supply grid without any converter. And here today the highest defined class is the IE4. Since July 23, the IE4 is even mandatory in the European Economic Area for motors between 75 and 200 kilowatt.
Okay, got it. So for a certain power range, it's already mandatory to use IE4 motors. But what makes our Innomotics IE4 motors so special? I mean, I guess it's not a rocket science. Other companies are also able to build IE4 motors. So what's special about our motors? And do we cover the full power range? This would be interesting.
Exactly. So for sure, in this mandatory range, we are covering all the basic types with all the options and certifications, including the NEMA rating for the North American market, where the respective IE4 class is not even yet existing. But we have additional designs. So with IE4 motors with increased power, with IE4 motors with premium insulation for supply with converter without output filters. And we continuously develop our portfolio. So now we can offer IE4 motors starting from 2.2 kilowatt in 2, 4, 6 and 8 pole configuration. And I don't talk only about cast iron housings because we have something which is quite unique on the market. We have also IE4 motors in the lightweight aluminum housings.
Okay, so that means we cover a much bigger power range that would be mandatory. And this is good to know. And what about the even smaller powers, such as 1 kilowatt or even less?
So we have IE3 motors starting from 0.12 kilowatt, which is again ahead of the regulations which require in Europe IE3 starting from 0.75 kilowatt.
So I guess this is really a comprehensive and complete portfolio. So now, Erich, when we talk about starting these high-efficient motors, Siemens comes into place. So what kind of solution does Siemens offer here?
So Siemens is offering a wide range of motor starter solutions. So we have direct online starters, soft starters, motor starters. And right now, when we are specifically talking about addressing these challenges of starting high-efficiency motors like the IE4s, we are offering a new technology, a new product, which is brand new, being presented for the first time here at the SPS fair.
Okay, that sounds promising. But before you explain your solution, maybe let's go one step back and explain a bit more. Where is this big challenge in starting high-efficient motors? Maybe Thomas, can you explain that?
So when you upgrade to high-efficiency motors, it has impact on these parameters. So the efficiency goes up. Power factor typically bit goes down, so both influence the nominal current of the motor. Starting torque and maximum torque are typically increased. That's positive because the motor can accelerate the load better and also overcome overloads. And now we come to the topic of starting current, which is also typically increased. So you know that when the motor is starting directly on the network, it takes multiple of its nominal current from the grid for some time. And probably you have learned that it can be something like 7 times nominal current. But today, when we increase efficiency of the motors more and more, we can meet values even like 10 times bigger than the starting current.
And this is very important to consider for the network. This high starting currents can cause voltage drops in the application, which could also lead to a wrong tripping of protection devices. And that's why we need to take special care of this challenge.
Exactly. And from our side, we can help that a bit by offering an alternative design with reduced starting current, either catalog solution or customized. But then when we move to now to your field expertise, what can be done on the network side to mitigate the impact of the high starting current?
So what we are bringing up for the first time to the market is the SIMATIC ET200SP e-starter. So this new device offers a real groundbreaking technology to exactly address this challenge of the high starting currents and inrush currents. So we're covering with this device, with this groundbreaking technology, short circuit currents and also the topic about starting currents.
Okay, that sounds promising. So maybe you can explain a bit more what's behind this technology and what are the advantages?
Yeah, sure, Sabine. So the ET200SP e-starter uses silicon carbide MOSFETs, and it's a full electronic. This means we have the electromechanical components out of the device, which means we're switching completely electronically. This means that by leaving these mechanical components out, we can react with this device about 1,000 times quicker than a conventional starting device or even react 1,000 times quicker than a normal fuse or circuit breaker.
That sounds really fast. 1,000 times quicker.
Yeah.
Wow. Impressive. So, and what are the benefits then for the end users?
Well, you might think, okay, 1,000 times, what is it about? So a normal circuit breaker or fuse reacts about 4 to 8 milliseconds. We're in about 4 microseconds. This means that when it comes, for example, to short circuit currents, we don't even give the short circuit the chance to go up in the current, and we shut it down immediately, so the whole branch would not see even any of this short circuit current. So when we And this is the biggest highlight, because we don't have any fuse that needs to be replaced, and also no circuit breaker will trip because of these high starting currents. In addition, this is the part of the short circuit protection, and now talking about the topic, what Thomas said about the high starting currents. So here we address 3 topics. The first one would be the inrush currents or magnetization currents that we have with these high efficiency motors. So these are from the e-starter, they are completely neutralized. So we don't care about these inrush currents. And second, we're talking about and the inrush currents happens during the first half waves during startup. So the second topic is the high starting currents, which, as Thomas said, could go up to 10 or even more times the rated current. And with this, what we do is we have a new feature called Smart Start. So this feature, what it does is reduces the starting current of the application to about 30-40% of the typical direct value with a direct start. And therefore, we can see it better in the graphic how this function works. So when we have the direct start, we have the peak at the beginning, and also we have the same peak or a similar peak in the torque, which is causing stress in the mechanical part of the application. So when we activate the Smart Start function, all of a sudden we see a real reduction of these values. So we see in the starting currents that the values are reduced to 30-40%, and the starting torque we have almost like we would say a linear increase of the torque. So this reduces the stress, which is the third point, so the torque that the application sees is directly proportional to the starting current. So if we reduce the current peak during startup, we reduce also the mechanical stress caused by these torque peaks during startup. And therefore, the maintenance works and the mechanical wear on the application is also reduced.
Okay, which is for sure also a big benefit for the customers. So, sounds simple if you understand the technology, but it sounds like a perfect match for our high efficiency motors. So, thanks a lot for telling us about this new product. Yeah, Tomasz, when would you recommend to our customers to switch from IE3 to IE4?
So comparing a new IE4 and new IE3 motor intended for continuous operation 24/7, the payback time for the IE4, thanks to the energy cost saving, can be around 1 year. So we can say that IE4 motor is the best motor from 1 year onwards. But also customers are thinking not only about energy consumption, but also about the environment. And by using IE4 motors, they can better achieve their carbon neutrality targets. Because when reducing the consumption, they also reduce the CO2 footprint emissions. For any case, for any operation mode, we have an online tool called Innomotics Evaluate. You might know it also under the previous name SynaSafe. This tool makes it easy to make a decision by selecting from different options in regards to energy efficiency and CO2 emissions. This tool works also without any login, also on mobile devices, and has a benefits for the registered users like project handling or individual settings. There's also a new function, this is the mass evaluation. So the customer can even upload a complete list of motors in their plant and see where it makes sense to invest in high efficiency, preferably.
Okay, cool. So that means I cannot take the wrong decision because this tool will help me to find the optimum solution. And by the way, we also show this tool here on our booth for sure. Okay, Tomasz, let's say a customer is already convinced, okay, I want to switch from IE3 to IE4, even if it's not mandatory in the moment. What could you recommend to consider regarding the practical impacts and the mechanical side? Because the electric parameters we discussed now.
Exactly. So when upgrading to IE4, the motor might have a slightly different outer dimensions. Also, its weight will be higher because we need to use more active material. But the mechanical interface, I mean the motor feet, shaft, and then flanges, are standardized, and nothing needs to be adjusted on customer side, at least with Innomotics motors. Furthermore, the benefit is that the motor in IE4 is typically cooler at nominal load, so when the bearings and stator are running at reduced temperature, it has positive impact on the lifetime and reliability. And also it's easier to cool the motor down because of the less losses, so when it's in the indoor in machine hall, it's also a benefit for the facility.
Okay, so and this sounds like a lot of benefits, so it must be worth it to upgrade to IE4. Thanks a lot. So maybe coming back to our picture from the beginning, when you saw this athlete, it's a bit similar, yeah. More muscles is more weight, but it will be a perfect start and perfect for speeding up. So thank you very much for this interesting presentation, and for sure, if you want to know more. As we said, we have the Evaluate tool on our booth. Tomasz will be there to answer your questions. And for sure, you can also stop by the Siemens booth in Hall 11 and discuss with Erich for the new e-starter. Thank you very much. Any questions or something to add from your end?
No, looking forward to hear from you and seeing you there.
Yeah, I really appreciate this joint presentation together with Siemens. So thank you very much. Thank you.
Thank you.